Station, this is Houston. Are you ready for the event?
Yes, we're ready for the event.
Space Dynamics Laboratory, this is Mission Control Houston. Please call station for a voice check.
Station, Peggy and Jack, this is Charlie Precourt. Are you hearing me okay?
We're hearing you great, Charlie. It's good to hear your voice.
I am really jealous not to be on that side of the phone call, but it's really great. We got a room full of very excited people and students to talk to you. So I'm going to hand the mic over to them.
Okay, excellent.
Thank you. We'll dive right into our questions.
What did you have to do to prepare yourself and your body and your mind to be an astronaut?
Well, to be an astronaut, you do need to be physically fit. We are expected to do spacewalks, which does require some physical strength to some degree, and obviously we have to be fit in order just to do the job. But I think probably the most important qualification for being an astronaut is to have studied in some field in math, science, or engineering. And we have astronauts in all of those fields, all different science fields and engineering fields and aerospace fields, and pilots like Jack.
So it being the International Space Station, as part of your astronaut training, do you have to learn different languages?
Yeah, and absolutely you do. At a minimum, we have to know English and Russian on the space station. But we also train in Japan, in Germany, in Canada. We go all over the world for our training. And more importantly than just the language is you have to understand the culture so that we can work better as a team, both with our ground team and our team here on the space station. The world is getting smaller, and you have to be more worldly. You have to work on your language skills in order to find your place in it.
What are the psychological effects of being in such a confined space for such a long amount of time?
Well, actually, the space isn't all that confining. We have 16 different modules, and each of them is about the size of a school bus. So there's a lot of space in here, and with only, right now we only have 5 crew members on board, so we spend a lot of time working every day, and we might not run into anybody until lunchtime when we join up together to eat lunch.
What is the best food in space?
Yes. Actually, my answer would be everything because it floats. So I'm going to demonstrate. I like coffee balls because I like coffee, but I figured you guys would think that tropical punch is kind of cool because it's red and kind of awesome. Here we go. So you can make a big ball because of surface tension of the water, or
Tricks by Jack.
What kind of trash does the ISS produce, and how much of it will be burned using the Cygnus spacecraft?
Actually, we do generate quite a bit of trash from all the different scientific investigations, and we do hardware upgrades all over the station. So anything that gets shipped up here has to be packed in foam and padded to handle the launch loads. So there's all kinds of trash that gets generated. And we do luckily have trash trucks like Cygnus and Progress and HTV that will take our waste away, and it does burn up in the atmosphere. But again, these are small school bus sized modules that carry away quite a bit of trash. And so luckily for us.
If you could give your 17-year-old self one piece of advice, what would it be?
Well, I'd give the advice my dad gave to me when I was 18, and that was, I dare you to dream. That has two important parts. First off, the dream part. Only you can find what it is that's your passion, what it is that's your dream, the thing that makes you just lights a fire in your soul. You have to define that for yourself. And then the second part, I dare you to dream, is that no one is going to give that to you. Not everybody gets a trophy in life. If you don't work really hard at it, really hard at your passion, it will never happen. I can guarantee it. So those are the two pieces that you need to find. You need to define that dream. You need to find your passion, and you need to follow it with all you got.
What do you do for fun?
Actually, probably the most fun thing is looking out the window. But I tell you what, just every day being here in space, floating, figuring out, how many circles you can make crossing the laboratory module, or, coming up with these fun games that you can't do or play on Earth because we have lack of gravity here, which makes the science so interesting as well. But it absolutely is a fantastic environment to work in.
Do you ever play any instruments aboard the space station?
Why, that is a fantastic question. I don't, but we just so happen to have someone who does. He may be floating by now. He speaks lots of languages, plays lots of instruments. He's not good for our self-confidence as people, but kind of an amazing dude. That is our Frenchman, Thomas Pesquet.
What is the adjustment process to life in space?
Actually, the biggest adjustment is that lack of microgravity I mentioned before. Learning how to work with tools that will float away if you don't tape them down or Velcro them down or have them contained in a bag of some kind or another. That's probably the biggest adjustment. But physiologically, our bodies are adjusting also without gravity pulling on our fluids. We have a fluid shift that occurs initially when we get up here. So that's also occurring as well.
Does time seem to pass slower, quicker, or not at all while in space?
Oh my gosh, so much faster. You know the adage, time flies when you're having fun? I mean, we have fun all day. We're doing science, we're fixing stuff, we're looking out the window, we're taking pictures. Everything that we do is just fun. So I can't believe it's Friday afternoon of another week. It goes way faster.
What if you run out of materials before you can get more?
Well, it would be a little slow if we didn't have as much to do, but I think we could probably entertain ourselves for a few days. No, and our resupply is very important for what we're doing now because we're doing so many different types of research experiments that we do need some resupplies. But we have a lot of experiments that can run without too many resupplies, and we would continue working on those, I'm sure.
My name is Amy Iverson. I'm asking the question for Thomas. What are some of the current experiments that you are doing, and what can be potentially learned from them?
Man, it's a hard question to answer. Just in my time on this station, and Peggy's many more, there's over 300 experiments that'll take place. We're doing everything from human physiology, Peggy and Tomas spent the last couple weeks working on a bone investigation study. We can grow perfect crystals, so we can look at virology and immunology. We have an experiment on board that is looking at new ways to create lightweight and stronger alloys. It's just the expanse of scientific experiments that are on the space station right now is absolutely mind-boggling. So to say which ones will have the biggest impact, I have no idea. I do know that this place and what goes on here is changing humanity for the better.
What's your favorite thing about space?
Being in space. Just being able to float, relax. Every orientation that you're in feels the same. It's an amazing experience, and just being here is what makes it special.
What are your jobs and responsibilities on the space station?
So that's one of the things that makes it so interesting, is because every day is a bit different. We may be doing something one day, and then Peggy does it the next day, and Tomas does it the day after that. There's so many different things that we're doing because there's so many experiments. Our big jobs are maintaining the station and then the science. We also have to, clean it. Housekeeping is one of the things that we do. But for the most part, we're jack of all trades, master of none. And the big thing is that Peggy is the commander. That role is most important in emergencies. Other than that, we're kind of a team all the time, just getting the job done every day.
How does zero gravity affect your body, and do you get stomach aches?
Zero gravity actually does have a lot of effects on your body because you don't have gravity pulling on your body. The first thing I talked about was the fluid shifts. That may have some impacts that we've seen, some changes in eyes in the astronauts. We've also seen without significant exercise, we'll have bone loss and muscle loss. So we're studying those things, figuring out what it takes, what's the minimum exercise amount required to keep us healthy, because when we do those future exploration missions, maybe one of you will be participating, and we'll have it all worked out and figured out exactly what the minimum is required to keep you healthy and safe. And, you might think with the lack of gravity, you might have a stomach ache and eating. I don't really feel any different sensations while I'm eating, so it's great. Still enjoy eating, too.
What are the procedures you follow in the event of an emergency?
Yeah, that's a great question. We have a lot of different emergencies on the station that we train for, but the three big ones are fire, rapid depressurization if there's like a hole in the station, and then a toxic atmosphere, most notably ammonia, because our cooling system outside uses ammonia to cool things down, and it's not very good for you. So we train those until we have them basically memorized, because we have to have a memorized response and be able to react quickly. That's where, I mentioned that it's kind of we're all working together. Obviously, that's true, but during an emergency, you need to have a boss, and that's our resident space ninja, Peggy, telling us what we need to do and where we need to go so that we can all get home safely.
What do you do during your free time in space?
Actually, looking out the window never gets boring because we get to see the Earth. We're going around the Earth 16 times in a day, traveling at 17,500 miles an hour. We see a sunrise and a sunset about every 45 minutes. So it's always amazing to be able to look out the window and see something new. The light angle will be different. We'll be in a different inclination. Things are just always interesting looking out the window. But of course, we're up here with just four other people right now. And so we can talk to our family and friends on an internet protocol phone when we have the specific satellite capability available. So it doesn't really feel that we're too separated from them. And it's nice to stay in touch with them via email as well. So that's most of our entertainment. And then, figuring out astronaut tricks.
What does it feel like knowing that you're one of so few people that has actually been in space?
Well, honestly, it's very, very humbling to be a part of that group. But it humbles me. It also inspires me to make that list a lot bigger. And I think that your generation, all of you students that are there, if you're engaging in those science and technology, engineering, math type of pursuits, you're going to be the fuel for our engine that takes us into the next generation. So I really feel that space exploration is about to really, really take off. We're building the infrastructure with commercial endeavors, as well as the largest rocket we've ever built. So Space Launch System is going to be bigger than anything that's ever flown. And all of this is coming together with a commercial enterprise, both for commercial spaceflight and cargo to the station. And then you have this wonderful laboratory. So you are the generation that's going to take us into the heavens for good. And I'm really excited for that list to get huge really soon. And hopefully your names will be on it.
Is the ISS able to be driven?
Actually, that's a really great question. The ISS, the truss that holds our solar arrays is the length of a football field long. So it does take quite a bit of momentum, in our case, to drive the ISS. And we have these control moment gyros that are spinning at 6,000 RPMs, and we can change the momentum to move the station, even something as large as this football field-sized structure that we have. And if we need to increase or decrease our altitude, for instance, for debris avoidance, if we see something ahead that we need to avoid debris, we can increase or decrease our altitude with the thrusters in the aft end of the Russian segment, so we can thrust up or down. And we also can change our altitude to meet visiting vehicles, to optimize for them as well. So yes, it is drivable, but not maybe in the sense that you might think.
What weird stuff have you seen in space?
Well, pretty much everything's weird. Don't point at me. That's not nice. Everything's weird. You get to see things floating and spinning, and when you eat your food, I was eating pudding last night, and I cut a little hole in the packet and I squirted the whole thing onto a spoon, and it was this gelatinous jello mountain of yummy, and I mean, that's just weird, but it's cool. There's just so much cool up here. Everything is weird. Sitting on the ceiling, how's that for weird? But the thing about it is there's so many different opportunities for you to stretch your mind and redefine reality and just grow as a human that I absolutely love this place.
Thank you, Jack and Peggy. We just have a couple of minutes left, so we have 2 more students with some questions.
What classes do you have to study in college to become an astronaut?
Well, it's kind of like Jack said, any field, math, science, and engineering, but you really need to pursue something that means something to you, that gives you the passion to want to study it, to want to be an expert, and that really drives you. And that's what you need to pick. So there's nothing specific other than being in a math, science, engineering, technology kind of field.
Do you have internet in space? And if so, do you spend much time on computers or on phones surfing the web?
Well, I'm kind of a computer geek on the ground, but up here, not so much. Our internet, we have the capability to do internet, but I'm going to use a word some of you probably don't even know what it means, dial-up. It's really slow. Like back in the old days where we had a modem and it would, you know, speed was measured in baud. Do you guys know what baud is? It's really slow. So we don't do much with it, and honestly, it would be a waste of time in space to be spending a whole lot of time on the internet up here. We have some people that can help us and post things so that we can share what we're experiencing with those on the ground, but for the most part, we don't spend a lot of time on it.
This has been an incredible experience. We are so thankful that you would join us today, and I'm going to turn this over to your friend Charlie to say goodbye.
Jack and Peggy, that was awesome. And Jack, you alluded to what these students can be in their future, and really appreciate the connectivity there from space station on into the deep space journey that we're on. Thank you so much. And these are, in fact, our future scientists, engineers, and our workforce in the future of space, and you did great. We really appreciate the opportunity.
Well, thanks a lot, sir. And I don't know if you remember, but you were the guest speaker at my test pilot school graduation, and you and Peggy and, you know, you guys inspired me and others, and I think it's just a self-licking ice cream cone of inspiration. We need to keep this going and continue so this next generation can be even better than we were.
Indeed. Like I said, I'm jealous, especially that I'm not the one sitting on the ceiling up there today. Keep up the great work, both of you.
Station, this is Houston ACR. That concludes the event.
Thank you to all participants and guests from Space Dynamics Laboratory. Station, we are now resuming operational audio communications.